Hello again. As you know, I'm Eli the Computer Guy over here for EverymanIT.com, and today's class is Introduction to Risk Assessment. So today we're going to go behind the theory of doing risk assessment for your systems and your networks, or for your clients' systems and networks. So the first thing that we should talk about is, what is risk? Most people don't really understand what risk is. Risk is simply the concept of the likelihood of loss, the likelihood that the business is going to lose money. So what is the risk of a computer shutting down, and how much money will that cost the business? One of the things that you should think about is, in order to do risk assessment properly, you have to understand both technology and business. A lot of technologists, a lot of computer geeks try to go into risk assessment. They try to go into computer security, and they don't want to understand business. They don't want to understand finance. They don't want to understand, return on investment and total cost of ownership, et cetera, et cetera, et cetera. Well, let me tell you, from the real world, the business people, the people that are going to write the checks for the security systems you're going to install, etc., they need business reasons for why they are going to do something. So it's not important to say your systems might get hacked. To a business person, who cares? Okay, so some hacker out there goes in and they see the pictures of my cute corgi dogs. That's not a business problem for me. What is a business problem is if somebody from the outside world can hack into your systems and steal trade secrets, or create a liable situation where your client's data is stolen, and then you get sued because the client's data was stolen. So that is what you need to understand about risk assessment, and when you're going in to do risk assessment. Not only is it a technological thing, not only is it, are systems up to date? Do systems have antivirus? Is there intrusion protection or detection systems out there? But it's also, what is the return on investment for installing antivirus software? What is the return on investment for installing a good firewall, etc.? So again, risk is the likelihood of loss, and what's important in doing risk assessment is not only that you understand technological solutions for security, but that you also understand the business justifications for implementing those security. So in this class, Introduction to Risk Assessment, we're going to talk about the theory and the thoughts behind this. So let's talk about risk. Now, the first thing that you really have to understand about risk is that risk is a business concept. So risk is the likelihood of loss, or the likelihood of financial loss. So how this revolves around you is, what are the chances that your systems are going to cause financial loss for the business that they're in? So if your systems go down, how much money will you lose because of downtime, etc.? So risk is a business concept. So this is a big thing to understand when you're going in to do risk assessment. So when you're thinking about risk, and when you're thinking about loss to your business, loss can come from a number of different places. So you could have downtime. Downtime, of course, is, the server is down, whether it's viruses, whether it's a power supply blowing, whatever it is. The systems are down. They are not functional. So with downtime, your business will have a loss, depending on what kind of business it is. It may be a small loss, or it may be hundreds of thousands of dollars. If Facebook servers go down, there's downtime, that costs them a lot of money. When you're looking at risks, you're dealing with fraud. So, people trying to fraudulently purchase products from your company. So let's say, if you have an online company and they use fraudulent credit cards to try to buy your downloads of something. So your business can lose money from fraud. So what is the risk of losing money from fraud? Now you've got legal issues to deal with. So those great, wonderful people off in Congress that still really don't know what Facebook is, have decided If they may not know what Facebook is, but by God, they can pass laws on it. And so now we have all of these legal requirements coming out of Congress. Now, so if somebody hacks into your business's system, they steal information from the database, what are your business legally liable for? So, if somebody hacks into your database, that person may not actually make any money. You may not actually lose any money from that hacking attack, but because that database is compromised, you may get sued, or the business might get sued for not securing their data enough. This is important, like HIPAA. HIPAA is the Health Individual Privacy Protection Act. So if you go to the doctor and they put your information into a computer, they have to secure that information. If they do not secure that information properly and their systems get hacked, you can sue them. So with that, then you've also got things like trade secrets. So in some of these very competitive industries, people create, or companies create, trade secrets in order to be able to compete better. Well, if the competition is able to steal those competitive secrets, then the competition will basically be able to steal clients from you, and it's all bad. So these are the things that you're worried about. This is the risk that you're worried about. So risk, you're worried about downtime, not being able to do work. You're worried about fraud. You're worried about legal issues, hacking, data theft, etc. Now, when you're talking about risk, there's a formula that's created by smarter people than me that says risk equals threat times vulnerability. That's a little short, but so risk equals threat times vulnerability. So the likelihood of loss equals what the threat is times how vulnerable your system is. So basically, if you're worried about somebody hacking your system, the threat is hackers, and your systems are very vulnerable. There's no antivirus software. There's no firewall. Then your risk is high because threat is high, vulnerability is high, therefore risk is high. Now, on that, if you're worried about hackers, but you have good firewalls and you have good antivirus software, etc., your vulnerability is low. So your risk is probably somewhere in the middle. So threat from hackers, if your system is on the internet, you're always at a threat from hackers, but your vulnerability is relatively low, so your risk is, What you have to understand with this equation is I don't want you plugging numbers into this now, maybe forever. This isn't like you say threat is 10 times vulnerability is 1 means risk is 10. That's not really how it works. It's kind of like when I talked about the OSI model way back when. This is more of a logical construct for you to understand. Again, if you think, hey, my threat is high and my vulnerability is high, oh, my risk is high, we should do something about that. If you go, well, the threat's high, but our vulnerability, our systems are good, risks, I'll worry about dealing with that later. This, like I say, is basically just a mental construct for you. The big thing, all I would say, is with this equation, is remember that anything times 0 is 0. So if you have 0 threat times a high vulnerability, your risk is still 0. So if you're very vulnerable to tornadoes, but you're in a place that doesn't have any tornadoes, then your risk is 0. If you're out in the middle of the Mojave Desert and you don't have a lock on the server room door, well, people probably still aren't going to come in and try to steal your server because you're in the middle of the Mojave Desert. So just remember this, anything times 0 is 0. If your systems are really, really secure, so there's no vulnerability, but there's lots of threat, then your risk is still 0. That's the main thing to remember with risk. But like I say, risk is likelihood of loss. Important thing for you is likelihood of financial loss for your business. Remember, we are in support. Technologists are in support of businesses, so we've got to worry about the business stuff. How can businesses lose money? They can lose money from downtime, fraud, legal issues, hacking, data theft, etc. So when you're thinking about risk, think about this and think about the cost that the company would incur if one of these things happened. You know, when you're thinking about the equation, like I say, it's risk equals threat times vulnerability. We're about to talk about threat and vulnerability in a second, so we'll go more into that. I just want you to understand this basic concept now so that when you're doing the assessment, like I say, you have an idea of what's going on. So let's talk about threat. So threat are the outside forces that could compromise your systems. So, you know, when you're thinking about threats, most people, especially the technologists out there, when they think about threats, you know, they think about viruses, they think about malware, they think about, you know, hackers out of China trying to compromise their systems. Well, there's a lot more to threat than simply hackers, just simply the technological stuff. And it's what you have to think about, because remember, you are responsible for your networks, for your systems. So anything that happens to those networks or to your systems is your responsibility. Now, the first thing that you should worry about, and probably is more important than hackers in a lot of ways, is natural disasters. You know, it's funny. Most technology people don't think about natural disasters. They don't think about things like flooding. They don't think about things like tornadoes or hurricanes or windstorms or any of that stuff. Well, you know, if you have a flood come through, that flood can destroy far more stuff than a hacker out of China can. You know, a flood comes through and takes out your server room. I mean, that's just it. That's just go home for the day. Not only your servers crashed probably, but your data could be gone too. So when you are looking at the building, when you're looking at the facility where your systems are held, think about what are the chances a natural disaster could happen. What are the real chances a natural disaster could happen? I had this with one of my clients, one of my best clients. You know, went in there, set up a whole bunch of stuff, you know, surveillance systems, website, servers, whole nine yards. You know, after about a year we were talking, and I asked him, you know, why the building was designed in such a way. And he said, well, it was designed that way because the building was sitting in a floodplain, and that, you know, by code, if a flood happened, the floodwaters had to go through the building so it didn't cause problems elsewhere. Well, hey, guess what? We had set up their server room and everything on the first floor. So every 10 years, about like clockwork, a flood would come through this floodplain, coat the floor of this building with about a foot of muck and mud, and their server room was sitting on the first floor. So their threat was a natural disaster, and the possibility of that threat was very high because, well, it already happened about 4 times. So of course we, you know, moved their server room up onto the second floor to make it more secure. So think about things like natural disasters. Again, a lot of people don't think about it, but you know, where are you going to position the server room? You know, if you put it in the basement in a place where it might flood, that could be a problem. Again, you know, as the technology person, you should be conservative. You know, doing risk assessments, you should be as conservative as possible. So, you know, you may be in an area where the likelihood of a flood is a 100-year event. You know, Katrina was a 100-year event. Well, if you were one of the businesses that were sitting in the flood area, well, it was not a 100-year event. It was a today event. So if you're in an area and they do have things like 100-year events, if you possibly can, you should plan around them. You know, what happened? You may never get a flood. You know, there was a flood 100 years ago. You know, the next flood might be in another 100 years. Or it might be tomorrow. So look at that. You know, what are the possibilities for natural disasters? The next thing, of course, that can happen is system failure. So when you're looking for threats, of course, the threat of system failure is always there. What can make the threat of system failure higher is, are you guys buying high quality components? So if your network is built out with all you purchased brand new all Cisco equipment, the threat of a system failure is probably pretty low for your network. If you bought all secondhand Linksys gear, the threat of system failure is probably pretty high. Why? Because Linksys stuff dies a lot. So that's something that you should look at when you're going in, when you're looking at your business or your client's business. What is the quality of the equipment that they are using? Are they using Cisco equipment, or are they using some weird Chinese knockoff? Their computers, are they a name brand, high quality manufacturer, or are they something that they could just buy a dozen of off the internet for $100? Think about that. You cannot eliminate the possibility of system failure. You cannot eliminate the possibility that a CPU fan is going to burn out, or a power supply is going to burn out, or a motherboard just dies. I mean, that just happens. But the threat of that happening goes up based on the lesser quality that you're dealing with. So if all of your equipment is very high quality stuff, then the threat of a system failure is relatively low. If you're buying all bargain basement stuff, the threat of a system failure is relatively high. And that's something to really think about. The next thing is accidental human interference, problem, doing something dumb. Basically, somebody doing something dumb. So what is the threat that somebody is just going to do something that's retarded? And that is always high. The threat that somebody is always going to try to do something stupid is always, 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 I don't care who you're dealing with, pretty high. So what is the threat that somebody is accidentally going to delete the contact database and not mean to do it? What is the threat that somebody is going to go in and reconfigure all the network settings on the server, and I've seen this done before, and basically shut the entire server and the entire network down? What is the threat of a human accidentally doing something? Whether it's a boss, whether it's a secretary, whether we're the technician. Sometimes technicians, believe me, again, I had technical employees. Sometimes they just do retarded stuff. So the threat of accidental human problems. And then finally, the threat that you are most accustomed to thinking about, of course, is malicious human threat. So this is where somebody comes in and they steal the server. They hack your accounts. They do identity theft, etc. So these are people with malicious intent. Now look at this. I've done threats, and this is the last threat. So that's 4 threats, and only one of those is actually the malicious, the stuff that you think about as a normal threat. So now when we're talking about malicious human stuff, the first thing that we talk about is something called impersonation. The second thing is interception. And the third is interference. So these are the broad technical terms, I suppose, of what malicious humans can do to you. So if you start with the first one is interference. So what interference is basically where somebody just damages your business. They're not stealing information, they're not stealing data, they're not doing fraud. They just basically damage your business. So this is where somebody comes in and they steal your server. Again, not to steal the data in the server, just being here in Baltimore, we have a problem with that. You have crackheads. Crackheads have to supply their habit. So they go in and they're planning to steal a computer. They go to the first computer they see. They don't know what the F a server is. They haven't finished a high school education. So they pick up this computer and they walk out with it to sell it at the pawn shop. Well, that was your server. So basically, they're not doing anything more than damaging your business. This may be, you can see this now, like I say, October of 2010, we have all these copyright lawsuits going on right now. Well, a lot of the hacking groups out there are targeting websites of these copyright organizations and just trying to bring them down, doing denial of service attacks, etc. So they're not stealing any information or doing any of that. Basically, all they're doing is they're just simply trying to damage the business. So that's the first threat from malicious human, is just pure damage. Like I say, your business can't work. If somebody comes in and steals your cash register, it's very hard to ring up customers. The second thing is interception. Interception is the classical concept of hacking. This is where they steal your data. So whether this is where they steal information, let's say you're emailing information back and forth between one of you and maybe one of your sales associates or something, or this is where they come in and they hack the server and they pull out your credit card database. So interception is the classical concept of hacking. Basically, they are trying to acquire your data to do something with it. And then finally is impersonation. This is where they talk about identity theft. So basically, they are trying to become you within the world of the internet. So that they're trying to get credit card accounts for themselves, but that get billed back to you. So when you're thinking about malicious humans, again, you've got interference. This is basically just where they damage you. You've got interception. This is hacking, and basically in its classical form. This is where they're actually trying to steal data. And then impersonation this is where they're trying to become like you. Like I say, to take out credit cards or do stuff like that. The main point that ending on this whole threat note is, again, malicious human is one of 4 threats. Like I say, natural disasters can be huge. So don't count them out. Ask your client or your boss, hey, I don't suppose we're in a floodplain. It's surprising how many people will get office space in a floodplain and not even realize that. So if you go up to your boss and you go to your client and you go, I noticed there's a river over there and we're kind of on flat land. Are we in a floodplain? It might cause them to go, hey, I need to talk to the landlord about that. I don't know if we are in a floodplain. So, you could be in something like a floodplain. Again, we talked about system failure. The higher the quality of the equipment you buy, the less likelihood of system failures. We talked again, accidental human. Again, this is not malicious human. This is not where somebody is trying to do something dumb. It's just where they do, because we all do something dumb sometimes. So those are the threats that you have to worry about. Again, the higher the possibility that one of these things happen, the higher the threat level. So let's have an overview of vulnerabilities then. Let's talk. So we talked about threats. So these are the outside forces that could attack your system. So what are the vulnerabilities of your system? What protections do you have in place to protect your systems from these threats? And then what holes are there? So, when we're talking about vulnerabilities, you basically start talking about what do you have set up that protects your systems from these types of threats. So if you're talking about natural disasters, what protections have you set up for these natural disasters? So if you are in a floodplain and your server room is on the first floor of the building, then you are very vulnerable to a flood. Whereas if you put the server on the second floor of the building, you're not that vulnerable to a flood. So basically, if this actually occurs, what are the chances that it's actually going to damage the system? When we talk about system failure, as I said, what are your vulnerabilities to system failure? If you buy all high quality components, then you should have a very low vulnerability to system failure because, hopefully, your systems are very high quality and then parts will not fail very often. If, on the other hand, you buy very cheap, just crap from eBay, then your vulnerability is very high because you bought cheap stuff off of eBay. The chances that a system is going to fail is relatively high. That's the vulnerability for system failure. When we talk about accidental human problems, so people accidentally deleting the contact database, what is your vulnerability to that? If you have set up permissions correctly, sharing permissions or group policies on your server and on your computers, then although the threat of somebody trying to delete something is very high, the vulnerability is very low, because if they do not have the rights to delete a file or folder, then they will not be able to delete the file and folder. So even when they go to try to do it, they won't be able to do it. So the vulnerability is low if you set up the correct permissions, group policies, etc. Then, like I say, going off to malicious human interference. Interference, people trying to steal your computers. What protections have you set up for your systems? How vulnerable are they for getting stolen? If you have a proper server room, you should have a server room that is only dedicated to your servers and computer equipment. It should have a steel door and it should be locked. Preferably deadbolt locked, but nobody ever does that. But it should be locked at all times except when a computer technician is in there. So if you have that, the vulnerability for somebody stealing your server is relatively low. If you're like most people, who just put the server, on the desk beside their secretary or their assistant, then their vulnerability that something will be stolen is very high. Again, with something getting stolen, if you set up your office in the ritzy yuppie section of town, the vulnerability for somebody coming in and stealing stuff is probably less than if you go for the cheapest office space available and you go to the ghetto because in the ghetto things get stolen more often. So this is your vulnerability to somebody actually coming in and stealing or doing something nefarious to your systems. When you're talking about things like interception, so again, as we talked about with classical hacking, what is your vulnerability to that? Do you have first-class firewalls set up? Do you have antivirus systems set up? Do you have malware systems set up? Again, do you have group policies so that hackers can't get in and start messing with all your systems? If you have a proper security system set up, your vulnerability to interception, to hacking attack is relatively low because you've put up these protections. If you don't have antivirus on your systems and you don't have a firewall and anybody can do whatever the hell they want on their computers, then your vulnerability to interception is very high. Anybody in the world can probably come in and hack your systems. And then finally, things like impersonation. Again, this goes to how well do you do things like destroy documentation? So if you're worried about identity theft, do you shred all of the information that might be valuable? When Eli the Computer Guy, the repair shop, was around, I had 5 shredders in this building because any piece of paperwork that had any information about the client had to be shredded after work on their computer was done. We didn't keep passwords, we didn't keep any of that. It all went through the shredder. Why? Because I did not want the vulnerability of somebody being able to steal my client's information and then just going on that little rabbit hole to hell. So that is what you have to think about with vulnerabilities. Threats are the outside stuff, the flood coming at you. So a flood comes at you, that's a threat. What is your vulnerability? If your server is sitting on the first floor of a building in a floodplain and a flood is coming, you are very vulnerable. If, on the other hand, you move the server up to the second floor, or even better, if your server is now off in the cloud somewhere, then you don't have any vulnerability. Again, as I talked about before, when you're thinking about risk equals threat times vulnerability. So again, if we're talking about that business that was in the floodplain, if they moved their server off into the cloud, off into like Amazon Web Services, then they had no vulnerability. So the risk was 0. So although their entire building might get flattened by a flood, they weren't vulnerable to it because it didn't matter, at least as far as their systems were concerned. So that's what you've got to think about, when you're dealing with risk. Risk, threat times vulnerability. Threat is the outside, people or forces that may attack your systems. Vulnerability is how vulnerable your systems are to it. Again, if you have no threat, then risk is 0. If you have no vulnerability, then risk is 0. As I said before, don't try to plug in, at least at this point, real numbers. Don't put vulnerability is 9 and threat is 10, which makes risk 90, because at this point 90 doesn't mean anything. I mean, I guess you could give it to your client, but it doesn't really mean anything. That's vulnerability, threat, and how that comes into risk. So since we've talked about vulnerabilities, let's go over talking about ways to protect your systems or to lessen the vulnerability for your systems. Now, of course, the first thing that everybody thinks about, because we're all computer people, are the technological safeguards. So things like, do you have firewalls set up? Do you have group policies set up? Do you have antivirus software? So these are the technological ways that you can protect your systems. Do you have a good backup system? Do you have some kind of redundancy, some kind of clustering system? Firewalls, policies, antivirus, sharing, etc. These are all, technological solutions where you can go out and you can buy a server, or you can buy a router or any of that and configure it to try to protect your systems. Not just, like I say, from hackers and viruses coming in, but so that even if you do have a system failure, you may have automatic recovery. So virtualization has become very, very popular now. So you can have a technological protection for your systems where you have virtualized your servers over multiple physical boxes. And if one of those physical boxes gets shut down for some reason, the server automatically pops up on another one of the virtual computers. We'll have a little virtualization track at some point, but you can actually have that now. So those are the things that you should be thinking about for technological ways to protect your systems. Now that, of course, we have lots of classes on that, and everybody thinks of this kind of stuff, firewalls, antivirus, all that. Beyond that, though, you really need to think about things like physical security and what's called operational security. So these can be just as important as your technological security measures. So what physical security means is it's the physical security for your devices and for your systems. Do you have a good lock on the door? So, if all your computers are in a building, is there a good lock on the front door of the building? Can anybody in the world break in? Physical security deals with this. So this is where, like I say, you put all of the servers into one server room, and then you make sure that server room is locked to make it more difficult to get in to break, to steal the server. Or for physical security, a lot of businesses now, you have multiple offices within one office space. If you force every single person to lock their doors, then even if somebody breaks into the building, they then have to continuously break into all these doors in order to steal computers. So if you have good physical security setup, you may make it just too much of a pain in the butt for people to be able to actually gain access and do any damage or steal anything. Again, an irate employee, if a server is sitting out in the open where anybody can see it, he can come along and just kick that thing because there's no physical security around that server. Whereas, again, if you have your server sitting in a server room, and I keep saying this because more small businesses should have their servers in server rooms, but we're not going to go into that right now. If it's sitting in a server room, even if the person wants to kick it, well, then he doesn't really can't get to the server to kick it and cause it any damage. Now, beyond physical security, again, just as important, physical security is something called operational security. Operational security is the security around how things happen or where things are stored in the business. So operational security, imagine if somebody did want to come in and steal your server, but there was no room in your building that said server room on it. The idea with operational security is that people don't know where the important things are. Only the important people know where important things are. So if somebody came in to try to steal your server, and they came into your building, that they would have no idea where the server room is, where the computers are kept, etc. Beyond that, operational security is also who gets access to things like the server room. We had a big problem with this, back, doing computers in the late 90s when we were dealing with old telephone systems. So before we went to voice over IP, we dealt with something called these via Definity telephone systems. Well, what they were was big cabinets that hung on the wall, and you had cards that slid into these cabinets. Well, some of these cards were worth up to $30,000. A lot of businesses, we were warned, since they had no operational security and very little physical security, what would happen is people would walk in off the street in little uniforms that looked like they were with a telephone company. They would walk in to the server room with one of these telephone systems in it. They would start yanking out all of these cards and throwing it in their little tool bag. They would close up their tool bag and they would walk out and say, "Thank you, ma'am." Well, the reason that they were able to do that is because there was no access control onto that server room. Anybody in the world was allowed to just walk in there and do whatever they wanted. So that's something that you have to think about with operational security, is who's allowed to know what. If somebody just walks in off the street and starts asking you about your server system, are you going to answer their questions? I had that. I've had, people walk in and start asking me about our internal network. And I told them to pound sand. And they said, no, seriously. No, we're here for business. And I was like, yeah, but there's no reason you need that information. I will never, ever, ever give you that information. And so operational security is basically security around how things are operationally done. Where is the server room? Where is documentation? Things like point of contact. Who's allowed to access the server room? This can be very important. Then, when you're talking about protections and all that, you need to think about documentation. One of the biggest problems that I've dealt with companies is that there is no documentation. There's no safe place for information about how things are configured or how things are set up. Again, one of the risks or the problem with risk is downtime, right? So if you want to get systems back up and running, a lot of times you need information. You need passwords, you need point of contact, you need all that kind of stuff. Documentation is actually a protection for risk, because if your system goes down and a technician can walk in and they can see how the system was originally set up, they can get a new system back up and running a lot faster. Or let's say your internet service goes down, so you have interference. You're not able to do business like normal. Well, if the technician comes in and they go, okay, I need to talk to your ISP, if somebody can go, okay, here's the ISP's information, this is our account number, this is who you talk to, everything is going to get fixed a lot faster than if you walk in and go, okay, I need the information for your ISP, and they go, oh, yeah, I don't really know who we use. So documentation, like I say, is very important. Along with documentation, again, one of the big problems you have with a repair business, is making sure that all the software and everything is kept somewhere that's accessible, where you can understand what's going on. Again, if a server crashes, do you have the server disks to be able to restore the server? Or are those disks just sitting willy-nilly? I've seen that countless times in the real world where I knew exactly what to do. It's like, okay, your server's dead or your system's dead. I need these specific disks. I can tell you exactly what disk I need, and I can tell you once I have that disk, it'll take 2 hours to restore everything. And then we spent 5 hours looking for the disk, and then we had to order the disk from somewhere else, and it was just bad. So having the documentation, having all your software, that is one of the protections you can have. And then finally is, what is your disaster plan? So if something does go wrong, what is the plan? Who gets called for what? This is a really big deal. If the servers go down, what is the plan? First you call this IT guy, then you call this IT guy, then you call that IT guy. Having a disaster plan is a very important thing. Basically, anybody who's in any position of power within your business should have an idea of what the disaster plan is. If the server systems go down, this is the plan. These are the steps that we are going to take. The better your disaster plan is, again, with risk, if something does happen, the quicker you can get everything going again. So again, even if that flood wipes out your business, if you've set up a backup system properly, you could then upload all your data to some virtualized server on the cloud, and you may not have a building to work out of, but your servers are now functioning as well as they can up on the cloud, and the business can function. So everybody may be working out of their house in their pajamas at this point while the building is rebuilt, but you are, as a technologist, responsible for the technology. So as long as the technology is working okay, you're fine. So what is the disaster plan? If a disaster happens, what are you going to do? These are the protections that you can have for the event of risk, for the event of something catastrophic happen. Again, everybody thinks about technological safeguards. It's a very important thing, but it's not the only thing to fixate on. Again, physical security, making sure there's good locks, making sure there's bars on windows if you need it, etc. Operational security, who has access to the server room, who is allowed into the building. A lot of these big businesses allow anybody in the world just to be able to walk through the building and scope it out. You should have operational security. You have a receptionist. You can't go beyond this line unless you're allowed through. Again, documentation and where things like software are stored. Huge. If a system goes down, again, downtime is lost money, getting systems back up and running. And then overall, what is the disaster plan? When disaster strikes, what are you going to do about it? So now we should talk about something called mitigation. The way I think about mitigation is basically mitigation is trying to make bad not so bad the next time. So mitigation is the process of when a disaster happens, or when something catastrophic to your system happens, you fix what happened, you look to see why what happened, and then you try to prevent it from happening in the future. Or if you can't prevent the disaster from happening in the future, you try to make the consequences less bad, as I would say. So basically, you have the event, you have something bad happens, then you of course go to response. So then you respond to the problem. So a server crashes, etc. So you have the event, then you do the response. This is where you do your disaster plan. This is where you pull out all your documentation, etc. After that, you analyze what happened. So why did this event occur? So let's talk about, let's say, I was talking about, when people buy crappy equipment. So you have a server that runs your entire business, but the boss bought it off of eBay for $200. So the event is that your server crashed. So you respond to it, however you respond to it, you get the server back up and running, and you look at it, and you analyze, and you say, well, why did the server crash? And you say, because it was bargain basement parts. I'm surprised it lasted this long. So what you do is you go into what's called the mitigation process, and with that analysis, you say, if we had higher quality equipment, the chances of our equipment failing would be less. So that's hopefully where you then go to the boss or the owner and you say, we need to purchase higher quality equipment. So then you purchase, and that's part of this mitigation process, you then purchase and implement the higher level equipment so that hopefully the event doesn't happen again. If the event does happen again, then you go through the response. You do the response, then you do the analysis, and then you do mitigation. So the idea with mitigation is you're trying to keep the events from happening again, or at least trying to make them so that they're not so bad. So let's say that your computer, your server gets infected with viruses. You get the viruses out, you analyze the problem, and you say, well, hey, none of the computers on the network has proper antivirus software installed. So your mitigation is to install proper antivirus on all of your systems. Well, that is going to mitigate the impact of a virus in the future. So of course we know with viruses are real bastards. You can't always protect against them. So you will install the antivirus software in the future. So let's say this first event was absolutely horrendous. It took out 20 of your computers. It was a pain in the butt. Well, if you get a virus in the future, maybe it only takes out 5 computers because you've put that antivirus software on. So then you can respond to the event. So you get those 5 computers back up and running. Then you analyze and you say, why did this happen? You know, why did the computer still get viruses? And you go, oh, we don't have good group policies in place. If we had good group policies in place, the chances that viruses would cause so much damage are less. So your mitigation would be to improve your group policies. Then let's say a virus hits again in another year. Maybe it takes 2 computers out. And then you go to the response, then you analyze, and you say, well, what can we do about this? And somebody comes up and says, hey, you know, there's those antivirus firewalls out there. Maybe if we implemented one of those, it would keep the problem from happening. So then you install an antivirus software, etc., etc., etc. The main thing to understand with mitigation is you're trying to either prevent or make less bad the next occurrence. Like I say, we cannot prevent all disasters. The goal, especially as technologists, is to make sure the disaster doesn't wipe out our business. If the disaster happens and it wipes out all the systems and all the servers and all the contact information, then we're done. Then we're toast. I mean, the business is gone. We're looking for a new job. If you know, we've come up with something, so maybe the server is dead, but everything got backed up into the cloud. Well, hey, we still have our data. So what can we do to try to mitigate this happening in the future? Again, if it's flood, maybe you put the servers up in the cloud or something. But this is the basic idea of mitigation. Mitigation is trying to prevent the event from happening again or making it less bad. You can never prevent all events. You just, like I say, you go in this cycle. When an event happens, you respond to it, you analyze why it happened, and then you do a mitigation. You try to implement solutions that will either prevent or make this less bad in the future. So we've talked about risk, we've talked about threat, we've talked about vulnerability, we've talked about the ideas of protection, we're going to talk about more in other classes, and we've talked about mitigation. So now we're going to talk about the most important thing for you, and that is, of course, money. It is greenbacks, because remember, we are infrastructure people, we are support people, we support businesses. Businesses don't exist for us. We exist for businesses. So when we go in to ask, demand, etc., better protection systems, server rooms, firewall, antivirus, etc., we have to have a business justification for doing it. You need to understand, you really need to have in your head, when a business person is looking at your proposal, they're going to look at the cost of what you're saying this proposal is going to cost, and then they're going to look at the benefit, the return on investment. If the return on investment is not probably a good bit higher than the cost, then they are going to deny you outright. So, you know, I've been talking about server rooms. So even if you build out like a little 5x5, I don't know, 10x10 server room, construction cost, it's probably going to cost you about $5,000, right? Well, if you have a small business, and, you know, they do email, and they have a little website, and yeah, they have a server, but if somebody lost a server, they probably wouldn't care. Well, if you go in and you demand a $5,000 server room, they're going to laugh at you. They're not going to go for it. Whereas, if you go into a company, you know, where they have salespeople that are doing $5,000 or $10,000 in sales a day, you know, you have 10 or 20 salespeople on the floor, so, you know, that may be, you know, $100,000 in sales a day. If the server goes down, the business loses $100,000 in sales. So you can go and you can say, you need a server room, or you need this antivirus software, you need this or this or this. Because the possibility of downtime, the risk, the loss, the possibility of monetary loss is high. So if you spend this money, you have less chance that you're going to lose the money. Like I say, this is a very, very important thing. Again, you know, getting into this kind of stuff, you need to understand not just the technological, you need to understand, not just understand how you're going to protect the systems, but you need to understand the business justifications for why. So this is where, you know, you talk to the business people. You make sure they understand that they trust you. They trust what you're going to say. So, you know, when you pull out these solutions that they actually listen to you. And then you have to look at, make sure you price out, what is it going to cost to implement the solution? And then what is the return on investment for the business person? Again, if the return on investment is the same or less than the cost of implementation, they're going to say no. If they spend $10,000 and they get $10,000 in benefit, they're just not going to worry about it. If they spend $10,000 and they get $50,000 in benefit, then they're probably going to worry about that. And that's the other thing with the money, and this is the other thing that's important when you're doing the risk assessments and you're trying to move your business or your client ahead with security, is you need buy-in from the people that will sign the checks. Again, this is where, sometimes it's office politics. Sometimes it's, I like you, you like me, so just trust me on this one. But you are going to need buy-in from the people that sign the checks. I saw this a lot, again, with my clients. I saw their systems were very vulnerable. I would walk in with a proposal, the ROI, everything was there, and then they would just say, no, we don't want to do that. And you have to understand at some points, you can't get them beyond that. So when you do the risk assessment, when you're looking, what is the threat? What is the vulnerability? What is the risk? If something happens, how much is it going to cost the company? Like I said, you're going to need buy-in from the business owners to actually, be able to move ahead and get anything. The best thing you can bring them is, like I say, numbers. So what is the cost of the implementation of your solutions? And then what's the return on investment? If those are equal, they're going to say no. If return on investment is twice what they pay, they're probably going to say no. You really probably want to see 3 or 4 or more times a return on investment than what the cost is. So that was a class, Introduction to Risk Assessment. We went over a lot of concepts here. Let's just let them get around your head a little bit. Remember, risk is the threat of loss. Remember, risk assessment, the most important thing you have to understand about risk assessment is this is a business concept. It is all about the money. It's all about the greenbacks. So like I say, when I said in the last part, when you go to the business people, you have to bring them numbers. You have to bring them figures. You have to bring them a reason why if they spend $10,000, it will save them, or it will probably save them $50,000. If you can't do that, they're going to say no. So as we said, risk is threat times vulnerability. If you have threat, threat is hackers, threat is natural disasters, threat is, people doing stupid stuff. If there is no threat, there is no risk. Vulnerability. Vulnerability is the protections or lack of protections from threats. So if a system is not vulnerable, again, there is no risk. Again, if the threat is flooding, and you move your server room to the second floor, then the vulnerability is 0 or close to 0, so the risk of damage from flooding goes down to almost nothing. If you put your server in Fort Knox, there may be people out there that want to steal servers, but the vulnerability is close to 0, so the risk is close to 0. So these are the things that you're going to have to think about. Like I say, when you're looking at risk, what are the risks of certain things happening? Again, we talked about protections. There's the technological safeguards. We talked about that in almost all of the classes. It's firewalls, viruses, group policies, all of that. But there's more to protecting your systems than simply firewalls and antivirus. There's physical and operational security. Again, do you have deadbolts on the door? Do you have a security guard walking around the premises to make sure nobody steals anything? Operational security. Who's allowed into the server room? Do you have a big sign plastered on your server room saying server room? I would suggest you don't. You put a little out-of-order bathroom sign on or something. If somebody came in to steal your server, would they be able to figure out where it is? In the old days with the Pentagon or with old government security agencies, they used to have long hallways with doors with no numbers on the doors. The reason is because if if you were supposed to be there, you would know the door to enter. You would know what room was room 105. If you were not supposed to be there, you would have no idea what room is 105. So that's the concept between operational security. Again, we talked about documentation. Documentation is huge. So if something happens, do you have the information, or does the technologist have the information to fix things? Do they have the username? Do they have the passwords? Do they have the account information? Do they have the software? Again, huge issue is, I go to a client site, I would know exactly what I needed to do, but they didn't know where their software was. And then finally, if the worst case scenario does happen, what is the disaster plan? We'll talk about this more in other classes, but if a flood does come through, do you have the backups somewhere? Can you get a system up and running, etc.? We talked about mitigation. So mitigation is trying to prevent future occurrences of the event, or if there is a future occurrence, making the repercussions less bad. So again, it's like if your network is attacked by viruses, so you install new antivirus software to mitigate the future chances of viruses taking over your network. Well, the next time, viruses may attack a little less of your network. So maybe you need to implement group policies. And then if the viruses hit it again, well, then you maybe need to put like some antivirus firewall. The idea of mitigation is every time an event happens, you try to make it so again, hopefully the event doesn't happen again, or if it does, basically that it is less bad. Finally, I talk about in a lot of these classes, is if you want to install or set up these security systems, you are going to need buy-in from the business people. You're going to need to go to them, and you're going to need to go say, this is what the proposal is going to cost. To get everybody set up on antivirus properly, it's going to cost $5,000. And for that, the benefit is going to be, this. And you can look at it. So if you've been with a company for a while, or if they've been your client for a while, you can look at them and you can say, in the past 6 months, we can see that you've had 1 week of downtime. I know that a day of downtime costs you $1,000. So you're out, let's say $5,000. We can install this antivirus software onto all your systems for $4,000. But, this is a 6-month period. So, year in, year out, that $4,000 investment is going to pay for itself plus more in 2 or 3 years. This is the type of thing that you're going to need for your business people to buy in and actually sign the check. If you just go in and you say, our systems are vulnerable, I need $20,000, they're not going to give it to you. So this class, again, was Introduction to Risk Assessment. Like, this is a lot of the theory. The next class we're going to get into more practical risk assessment, so you understand how to go in, how to look at things to try to do a risk assessment of your own. As you know, I'm Eli the Computer Guy, over here for Everyman IT. I enjoy teaching this class and look forward to seeing you at the next one.